Welcome back, ladies and gentlemen. It is time to move on to the game mechanics. Make sure you save this scene before going to another one by pressing Ctrl+S on your keyboard or Command+S on Mac. After that, double click the quick play scene to open it up, and first we need to add some sprites so it doesn't seem so empty. So the sprites that we want to add for this one are the 20 and 21. These are kind of the player objects. Of course, we want to reduce the size to 0.6. And we also want to change the names. So the big circle is going to be called target, I guess. And we want to assign it a tag immediately. So click on add tag. And the tag can also be called target, it doesn't really matter. The only thing that matters is that you memorize which one it is, but you can always check. So make sure you go back to the target and assign the tag. It's going to be located roughly here. And after that we want to do the same thing with this sprite, and this will be called pin. And the tag should also be called pin. Again, don't forget to go back and actually assign the tag. Now we want to change the background color. So go to your camera game object. In the camera component there should be an attribute called background. Click on that and choose whatever color you want. I will choose white for my example, just like in the original game. After that we want to make the target rotate, and we will need a separate script for that. So right click on our scripts folder, go to create and choose a new C# script. We can call this script target rotation script. Open it up in Visual Studio. And this script is going to be, I think, very similar to the script that we used to rotate the letters in the last game. We will not be needing the start method, however we will need a variable. The variable is going to be public, of type float, and we can name it rotation speed. Let's set it to 70 float for now. In order to make the object rotate, we will use the transform.rotate, and the direction of the rotation is going to be vector3.back. And after that we need to type in the speed of the rotation. We already have a variable for that, and it's going to be rotation speed multiplied by time.delta time. Make sure you save this, go back to Unity, select the target game object and drag this script onto it. Let's see if it works. Remember, if you want it to rotate quicker or slower, it's easy to adjust the speed right here because we made the variable public. After that, we want this pin to always fly up. So how our game is actually going to work is, we will not have this pin in the scene to begin with. It will be a prefab, and whenever we tap the screen, the pin will be spawned at this location, and of course it will start flying up because we will make it do that. So right now we need to worry about making it always fly. First we'll need to add a rigid body to it, so click on add component, go to physics 2D and add a rigid body 2D component. We also want to change the body type from dynamic to kinematic. That will make it move only when we push it to move. After that we also want to add a collider to it, so click on add component, physics 2D, and we will choose a polygon collider 2D. If we zoom in, we can see that the polygon collider is not very good, so this is when our polygon editing skills come to use. Click on edit collider. Try to make it as accurate as possible. It might take some while, but it's kind of important in this one. I think this should be okay, it doesn't have to be perfect. Don't forget to click the button again once when you are done. And also enable the isTrigger option. Now we will also need a script that will make this game object fly. So create a new C# script in the scripts folder and we can name it pin script. Open it up in Visual Studio. Let me just go ahead and close these scripts. First we'll need a few variables. A public float variable that's going to represent our flying speed, so we can name it fly speed or whatever, and we can set it equal to 20 float. After that we'll need a private variable that's going to be of type rigidBody2D, and we are going to name it pinBody. Finally we are going to need another private variable that's going to be of type boolean or bool. If you don't know what bool is, it's a variable that can either be true or false. And we are going to use it to determine whether our object should be flying. If it collides with something, then it should stop. That means it shouldn't be flying, of course. So we can name it shouldFly. At the start of initializing this script, of course we want the object to be flying, so we will set the shouldFly variable to true. And we also want to target this rigid body. So what we'll do is we'll type pinBody equals to getComponent, and the component that we want to get is of course the rigidBody2D. Don't forget to open and close the brackets since this is a function. And this should be everything for the start method. So let's move on to the update method. In order to make our object fly, first we need to test whether it should fly, so we will use a simple if statement. If shouldFly equals to true, so this means if our object should fly, we will be executing some kind of code. We will reference this rigidBody2D by typing the name of the variable, and after that we will type dot move position, and in the brackets we want to type in the new position. So what we are going to do, we will take the current position, so we will type again pinBody dot position, and we will add some value to it. First we need to specify which direction it's going to. We want it to move up, so we will type vector2, since that's the representation of 2D space, dot up. We are going to multiply that by the fly speed, and we are going to multiply that by time dot delta time, so it doesn't move too quickly. And this is everything that should make our pin object fly. So make sure you save this and go back to Unity, select the pin game object and attach this script to it. If we press play, we should see our object flying away. Unity has a bit of lag at the beginning of the simulation, so I'm going to move it down a little bit. That's everything for this lesson, and see you in the next one.